Okay, good evening. So, amazingly, the camera system is working straight up, which is amazing because I'm using my cell phone and doing a weird contraption, and often it's like it takes me 30 minutes to have it working. Okay, so few things. First of all, I had a brilliant idea. Instead of instead of speaking about study with me, we are going to rename these videos Brainmax with me, or just Brainmaxxing, because that's what we are kind of doing. We are Brainmaxxing. And unlike yesterday, let's try to have the computer make a little less noise because it was annoying. And it shouldn't even be doing that much noise because it's like, okay, it's recording, but so was Terry Davis, and I didn't heard his computer being out loud, so it shouldn't be that loud. That's why I moved the camera, also trying to get it a bit further from the fans. What if I try to... That's the... I want to add... Can I add some... I wanted to add like, for example, here I can add a filter, but here I can't. Yes, I can. But that's for the camera. It believes it's a camera. Filtre audio video. I forgot. Yes, okay. Let's try this one. Close. So it goes down to 0. Almost no noise detected. The funny thing we can do is that since it's recording in a specific format, it allows us to... Okay. Use video. The funny thing we can do is that since it's recording close, so it goes down to 0. Almost no noise detected. The funny thing we can do is that since it's recording in specific format. Okay, I guess we are reaching the present now. Okay, I think it's going to be a bit better. We'll see. So, anyway, okay, yeah, let's Brainmax. So, let me do something. You know what I'm gonna do? I'm gonna do this. I'm gonna do this because you may ask me why did I have like so many different routes. Actually, at the beginning of times there were only one route. It's weird how it counts because okay, yeah, I know, right? Because the maximum possible cards to give you is like 10,000, so it's saturating here. At the origin there was only one route, so that this way clicking one card I could review all the possible cards and not just like review the card, change deck, review the card, change deck, because I'm lazy. So what I'd like to do is just click here and it gives me all the cards and we just get going like that. So let's try to do that, and if we are fast enough, maybe we'll learn a new deck. Oh, not that much work today. Not that much work today. I think we are missing a block that I did not record. And this block, it was from 16 to... That's an honest block. It happened. Believe me, it happened. Okay, anyway, so let's get reviewing. What categories of GANs overperform? These are the there are the classical GANs, there are the conditional GANs, just the conditional GANs. Yeah. A bit rusty, perhaps. Examples of models of conditional non-supervised GANs. Generative model DLGM. What do? We send to the oracle the images with the lowest norm to their minimal perturbation. Two groups, non-parameterized, non-matched. Mano with Neyu. Nefi. Wilcoxon. Well, it's paired and non-parameterized. Post hoc test. Well, you just get random individuals for the first population. CRN. Okay, so first you init, then you eval, then you repeat while you still have some NFP. What you repeat is select learn for the name, like a combination. Repeat, eval, replace, and then you return best individual. Init, eval, while, select, crossover, repeat, eval. Yes. Evaluation, you simply compute the fitness for all the individuals. These are the main steps of the genetic algorithm. Two groups. Evaluation, selection, non-matched and parameterized. It's Friedman. T-test. The fitness is the quality kind of the individual. You use tournaments. No, you use elitism to get the new population. You keep a bit of the best parents and you fill with the children, offspring, children. Solution that the phenotype in downsides is it's computationally expensive. Become the best individual. Oh, sorry, I don't watch the answer. Unfortunately, misclicked. Let me just use the keyboard, like a keyboard warrior, to be faster. Characteristics of conditional non-supervised. G wants to minimize this objective so that D of G of Z is now 1. Conditional GANs, they use noise and they get noise and an input signal Y. Generator takes, oh sorry, it functions with paired data. Generator takes noise and signal. Discriminator takes the output of the generator and the signal, and it judges if the output matches the signal. The input, I mean. Minimax with, we have it every evening. It minimize G, maximize D of the espérance of the log of discriminator on X plus after the espérance of log of 1 minus D of G of ZZ noise. Let's say it's correct. What's the prior? It's the vector sampled from the distribution encoded in the latent space by the encoder. That's the population. BEAM was proposed by Kurak in 2017. Crossover, you take the two parents, you combine them, for example, with a 1-point crossover, and you have 2 children. Individual is one specific solution to the problem. Candidate, yes, candidate specific. Non-parameterized test you use when the data don't respect the parameterized hypothesis. General pseudocode of the genetic algorithm, or the genetic algorithm. After the crossover, you mutate children. Train VE, Y, elbow, not directly log resemblance. Because log resemblance involves an integral that is intractable in high dimensional space. Talking head, well, the paired data simply are the video of talking head and like facial features, voice, and this GAN, the generator upsampling network using fractionally stride convolutional layer. When the data are paired and parameterized. Well, you have again init, eval, combine. Okay. State, place and stop. That's simple. CRM, they are used to pair data artificially. It reduces the variance often. And yes, it's about the same seeds, of course. Of course. Simple, that's simple. I put it as easy because I forgot to say seed, but it's like obvious to me. This one at least. Bandwidth NAU, non-parameterized and non-matched. Replacement, while you have some NFU repeat. To choose the statistical test, first you check the number of groups, you check if you are paired, you check the parameterized assumption, and you just take a test. What is the advantage and downside of EM? It's simple to understand and represent, but it's hard to compute in a high-dimensional space. Specifically. How to obtain second? You run another tournament. Simulator judges if the image could be from the domain or if it's like a Fosser, the English one. When the algorithm stops when you have no more NFE, FGSM is single step adversarial, non-targeted adversarial attack. One step. First step, it's so you have your image, you have the loss of the classifier, you retrieve the gradient of the loss, you only hit the sign of the gradient. So like if you visualize on the slope of the loss function, you retrieve the gradient, but what only matters to you is where is it going? Is it going that way or that way? And what you want to do is you see the way it's going, you will go the other way, I think, because no, not the other way, because gradient is like it tells you how much each pixels or something, each neurons contributed to the loss. So you want to push that way. So you just take the sign and you take your image and you do x plus x becomes x plus epsilon times gradient of the loss function of the image and the label. Yes. I put it in difficult because it's a bit, anyway. The genotype is the representation of the individual manipulated by the algorithm. Quantity that measures to which degree it's the p-value. Mutation you apply to the individual random mutation on the genotype. Fitness. EM advantages. Okay, efficient when 2 plus, sorry, is that overlaps. On representation of units allow characteristics and data types resistant to outliers and always converges. Good performances, representation characteristics, type of tests, that's parameterized test, selection, crossover, combination. It's very little p-value prove. No, it doesn't prove it. It only disprove H0. Yes, it rejects H0. After mutation, you evaluate. Oh, sorry, I leaked. Number of function evaluation. When I leak, I immediately like watch away, not spoil myself, because else it's like a bad thing. So, oh, we are going very fast this evening. But because it's like things we've seen for the past, I don't know how many days. When to reject HO, when p-value is below alpha, initialization, combination, crossover. Marginalized variables, intermediary variables means when you add noise, instead of adding noise in several steps, you add noise in only one step. You gain some time. By default, 2 successive tournaments, can they choose them? Yes. By default, commutation apply solely to children. Yes. CRN, common random number. Choice of when to use t-test when it's paired and no, when it's not paired but it's parameterized. Crossover, mutation, analysis, single problem analysis, structure of the DCGAN, data's approximately, that's the normality. DLVM, it tries to find a function like p theta x, z equals pz times p theta x given z. Pipeline of statistical tests. I think it's a question where you just say check numbers of groups, check paired or not paired, check parameterized assumptions. Yes. So okay, it converges more slowly than 10 minutes. General pseudocode of a genetic algorithm. We've seen it already. It was the other kind of way. P-value is the value that tells you to what degree the data align with the hypothesis. When two groups, it's the paired t-tests. Parent is just individual chosen for reproduction. Two groups, what domain sorry, I was not thinking. What domain? It's the active learning using margins. Independence, well, does one run affect the next run when you repeat the runs for statistical robustness? I don't know the word for robustness in English. Okay, we were very fast. We were very much fast. Which is really great, but I'm telling you, we are not going to be that fast anymore. So we don't need the details anymore here, except here to add on maths. I'm really looking forward to do maths again, because mathematics is so important, so important, and I have so much math liking. Oh god, because in my first year of university I was literally doing math and computer. It was like 80% maths. and 20% cocktails. So it's very much important. Oh, come on. Don't be silly. Okay, so let's try to do the bias. And so yes, I was saying we don't need the details, except this one. This one can go, this one can go, this one can go. And that's it. That's it. And you can totally go at least. No, we need to keep it that way, but do that. And do that. So that's why I just like. Okay, so what is an evaluation bias? It is when you use some evaluation function, for example, the accuracy or some other specific functions that assess the quality of the model on the largest population, but that omits its error on some specific subgroups, or that hides, for example, high false positives or things like that. I'm confusing this one with training bias, I think. So evaluation bias is when data training datas, no, test datas, benchmarks, or okay. What I said is actually true because there is indeed the evaluation function, but it's more like evaluation bias when the datas, the benchmarks, the functions doesn't represent the targeted population that will use the product. Or that's the problem with this definition, is like it's very packed. Very, very packed. But okay, now I know. Okay, formally, true positivity rate given a sensible attribute. Error prediction and Y. Okay. What is equal opportunity? Condition expected when group size. So I think it's like, let me think. I think it's like the probability. True positive rate. To have probability to have 1 while you are of A equal A and the Y is 1 is equal to only the group changes. That's the technical, I think. Yes, I forgot the variable of the output of the model. Yes, so that's what matters, is that Y stays the 1. Y is like the environmental input to give a good. It just says whatever group you are on, it shouldn't matter how many times we tell you yes. Evaluation bias. So when the metric, the benchmark, or the test data don't reflect the real population using the product, or when they mask subgroups, disparity between groups. Yes, kind of. Okay, so evaluation bias. Do you have a bias here, or is it just like you run the model, you have like the benchmark, I think, model output? That's a weird. That's a weird illustration for model output. It outputs waffles, tables. Example of. Oh, so yeah, that's the dreaded part of this deck. So examples, because it's useful, but it's tough to learn because I never kind of properly learned them. Anyway, examples of bias of evaluation. Use one single metric. Okay. example. Let me think, because I have it in my brain somewhere, but it's quite far away, I think. I'm just curious about how is. Yes, see, it's communicating via Wi-Fi, even though I plugged my iPhone, so that's really weird. Anyway, so an example of a bias evaluation. I don't have it. It's like part of the. It's part of the definition. But okay, now I know, I guess. And the other two ones are same, and this one is new too. That's tough. But output. There's data. Whoa. To evaluate, well, you have test, validation data, benchmarks. Doesn't make sense. But okay, whatever, bro. Variables strongly correlated to sensible attributes. It's protected variables. Oh no, these are proxies. Yes, proxy attributes. I not guessed it. Proxy attributes. Okay, fair enough. Fair enough. Examples of. Okay, so thankfully we checked the other three examples. So the first one was simply using a benchmark to evaluate the model on which it was not trained, a benchmark that is different from what it was trained on. The second one was using an evaluation function that doesn't account for the. Oh, I might have nothing to eat. Check. Fucked up. Well, we are eating pastas tonight. What was I saying? So yeah, the benchmark thing is the function thing, and the last one is simply, well, we never know. I'm not checking the other two ones because they are leaks. So the first one was the benchmark. Yes, you use a benchmark to evaluate that is different from the benchmark you trained on. Kind of. Benchmarks, proxy attribute. So, train on the population and you evaluate another population different from the population of usage. Or you use a function that doesn't take into account the disparity between groups. Or your model simply irritates bias of historicity, bias of sampling, bias of selection. I've invented a bias. Okay, let's call it a day. Same shit. These are measures to balance inequality before training. In pre-processing and to mitigate bias. Examples of bias of deployment. This one is easy. I think it was used like in the justice department. It was used to help, but people just took it for granted and just. Anyway, I understand myself. It's a bad. Oh. I was not thinking it's about justice, but I was not at all thinking about this one. So let's not call it a day. That's bias of representation, I think. So many goddamn bias. Model is trained on the population and evaluated. Evaluation, yes, so you use a function that does not represent disparities between groups and so on and blah blah blah. And everyone whines and it's not cool. And demographic parity. You have demographic parity when I think it's you have demographic parity when the sensible attribute has zero impact in the output of the model. No, it's not true. It's only when the positive outcomes but well, by definition, if you have the same probability to have a positive outcome, you have the same probability of having a negative outcome also, right? Because the negative outcome is simply a linear transformation of the positive outcome, so it's correlated, strongly correlated. Or am I saying nonsense? Do I need to go back to math before trying to be smarter than the card? These are measures to mitigate bias in processing. Examples, it was the model used to predict recidive that was actually predicting sentences because the judges were like lazy and over-relying on the model. Examples of bias of aggregation. Example of bias of evaluation. You irritates from displayability bias, measure bias, and the last one. Not representation bias. Is it representation? Yes, it's representation bias. Examples of representation bias. Oh, I don't know. Don't ask me. And we've not seen this one before, even as part of another card. Let me check what time it is. Oh, we had time. Unfortunately, we still have so much time. 30 minutes only? And how far? We have a very long road. Very long road ahead. Lord have mercy. Lord have mercy on my soul. Maybe I should do it in the morning instead of in the evening because that's quite really tough. Exercise. Not that tough, but it's like so tired of having to, since I had to do it my whole life. I received the mail. That's a useless mail. We lost connection, I think, for a second. Let me dim the screen. So anyway, hopefully the next card will be easier. An example of a bias of representation. Oh, I think I have it. No, it's historicity, this one. Bias of representation. Isn't it like, for example, the only people on which we gather data for illnesses, for example, most people are ill people that are already sick. So the models are trained on sick people. So when someone that is not sick is analyzed by the model doesn't know how to behave. That's one example. The second one, and I'm not sure it's even a good one. It's a good one. And the other one, okay, it's not far away. This one is easy. So yeah, you have ImageNet, all from United States, and this one is the same as this one, more or less. Okay, it will be simple to get back to. Historicity, I think the examples were like woman earns less than men, and it's not a problem of sampling. It's the truth. Woman, I mean, that's a debatable fact, but it's an example. If it were true that women earn less, so that's the thing. And the other thing, I guess the other thing is like when you train encoding model, you know, often uh, they will encode a doctor and nurses, and doctors are always men and nurses always women. So this one is true. This one is absolutely not true. It's not the same example. That's kind of the same idea. It's like it's instead of earning pay, it's like CEO. Most CEOs are men from the Fortune 5. Okay. Let's call it a day. Okay, representation. So what were we talking about? We said it was easy. It's not going to be easy. Yes, okay. So there were the patients population. Above there was the just medical population again, but like women that are pregnant, it's a very subset, a small subset. So again, the model will be trained properly for them. And the one above, it was easy, but I kind of totally forgot. Let me think. Man, let me think. Woman above, uh, representation. Yes, that peak dopamine when you finally can get back the information you're looking for. It's the ImageNet one. ImageNet is composed majority mainly of images from the United States. I think like almost half, and for example, 1% of China. So it's bullshit. It's bullshit. Examples of historicity bias. Okay, learning bias. It's the one I said in the beginning, mainly about the learning function, I think. The loss function. Or the loss function or just the evaluation while training function. I think it can pass for like, because what does it say? It's simply not it's the it's elements you use to train your model. It can be the loss function, the evaluation function, the constraints, favor the group in its globality and not subgroups. That's okay-ish. What is disparate impact? Wow. I think it's disparate impact. I think it's when you have same TPR and same FPR. No, absolutely not. Okay, I have the previous one. I have it now. What are limits of this metric? Equal odds. Okay, so that's equal odds when you have TPR and FPR. Given a sensible attribute, values A or B, prediction R. I would say it just bend the truth, kind of. So it's not respectful. Yeah, it's expressed better. It's really constraintful and can lower the performances. Examples of aggregation bias. I know there is one. It's almost like the representation bias. So tired. This deck is so tiring. Maybe it's time for a small break. I'll catch you later, perhaps. Perhaps not. Okay, so I just had an interesting idea, at least one, about about because I know I want to try it like on some finance stuff, but I don't know. Not I don't know, but I'm too lazy to like build the system again, and also it's very expensive model. So let's just ask him. Uh, Look, okay, search on the internet. We have to actually. Yes, really weird. Search on the internet. Analyze reports and to find a stock that might be the highest term today and sell in which I the highest over highest. That's experiment. We are okay. I don't know if that's a good practice. I don't know if that's good practice, but yeah, I'm gaslighting him here, so he's not like it's not really doable. Blah, blah. I know, it's a dumb question, but it's like, well, actually, it's true. It's not that much of a gaslight. That's more of an experiment. I'm not trying to get rich over a week, but I'm just trying to see its capacity to do some finance stuff, and also let's see how much that costs. Dim the screen. Let me see how much it will cost. We'll see that if the model will pick it up. Actually, let me run the model at the same time. Well, wait a minute. We're in some finance stuff here. Oh shit! We are leaking some information here. Anyway, uh, so you let me update the portfolio. It looks quite interesting. And this is not that amazing. Yeah, he feels like he has to do his little animation stuff. Not not that necessary, but whatever floats your boat, brother. Let me see the usage. Jesus, holy moly, 20% a request is crazy. This is crazy. It's not usable. 5 requests per 4 hours. It feels like it's a free model. The free. It feels like the free subscribing. Jesus. Make sure you're. And he did not think for that long. Imagine in a code base when it thinks for like more than 5 minutes, it's over. It's over, bro. It's too expensive. Nonsense. Also, since now the Cloud code got leaked, and we saw that it kind of like overdid it sometimes and more. It's not even that proper. Like, why do you do that? Avoid, crowded mixed, test, TSM, best, asymmetric setup. Do you have TSM? Absolutely not. Key risk or move escalation, what market setup, nice. The disease is in one breath. TSM stage deliver signal most important in one printing test model. Based for unit topics. When code in White wins Charlotte for one. Okay. 17 morning Friday. Okay, we'll see if he's on some. If he picks up something there. See, we kind of regressed. Okay. I know what he's going to say. He's going to say the same thing again and again. No action. He's a no action guy, like Trump would say. Does he say this? I don't know. How much did we study here? Actually, currently, I mean, 29 cards. We did not even do half of it. I'm so tired, bro. So tired, boss. And for the week, it was like 2%. What's kind of funny is that it's not even that good. Many people say it feels a bit off and maxed. And compared to GPT 5.4, well, sometimes it's tied. Not that tied. Oh, it's Pro actually, so it's a bit. So I guess it's worse. But let's see, like an absolutely biased benchmark that is live bench. They feel so biased toward GPT, but let's see what they say. They kind of have a really scientific approach to the thing. There are some columns where five point 4.5 was anyway. That's so weird. That's so weird. That's so weird. See how like you get 1% for 3 times the price. It's not worth it. It's weird. It's really weird. Oh yes. Be a bit autonomous, boy. Maybe you just ask to send my info to Netanyahu whenever it's yes. Yes, do it. Shall we do a bit more? This part impact. I think we're going to call it a day. It's a bit late already. I'm gonna give you some kisses and okay, you want to see what the output is gonna be? Okay, we can. Oh, you want to bankrupt me? Well, at least I know he's going to be he's going to do a good work. Okay, let's see what he summoned. Macro holdings, monitor, switch, septic. Okay, so still no nothing. Let me check bench. There are some very interesting results. So interesting is actually that I don't know what to believe. Like benchmarks are contradicting one another mostly. Not mostly, but like you're the top 5 best model more or less. It's like what you can expect. It's the best. But his bench is like if I put it. So how much reasonable can it be? And I heard Kimi is going out also. But it was only through API. Oh, my eyes just got burnt away. Kimi is so cheap compared to Cloud. It's not the same capacity though. Kimi K 6 or something, or 27 almost. Oh, you guys not picking up. It's out already. It's out. Is it even 2.7 already? You guys are liars. The internet is lying. Because tomorrow we are Friday. We'll have like 2% in a week, so 8% in a month. Again, that's like enormous. You want to simulate? You want to have some dream? You want to dream with me? Let's ask him again. We'll ask him every day like a retard. And what about 8 push or year? 8. What? What is he doing? What are you doing, bro? He catch it himself. Maybe he's not that reliable. Are you retarded? Why would you do that? Why would you? You are scaring me sometimes. This guy is not beating Opus 4.1. See that how benchmarks doesn't mean anything. Like let's see on math what was the output. Mathematics. Well, that's the problem with benchmarks. Maybe on some very hard problems that he's seen already, he's better, but this computation that is brand new for his little neuron brain. Maybe it's tougher. Oh, wow, chill out. What are you doing? I'm not very much Brainmaxxing. I should stop the stream. It's misleading. When I'm calling the video Brainmaxxing, and what we do, we just overhype LLMs. That ain't it, boy.